Hi and welcome back. In this last lesson we're going to combine all the different things that we've learned about naming and writing formulas for ionic compounds. And here we are going to be thrown any ionic compound, and we've got to figure out how to name it or write the formula appropriately. So we're combining our knowledge of polyatomic ions, multivalent metals, and how to write the names and charges of multivalent metals, and just the general rules for naming ionic compounds. So here we've got a couple of things on this front page that we need to remember to use. Our periodic table, of course, first in just determining that we have an ionic compound. That's always your first step. Secondly, looking up whether or not the metal involved, if there is a metal as your cation, if it is a multivalent metal, and if so, remembering to use your Roman numerals chart. And when you see a polyatomic ion, or you don't recognize the name of an element and you can't find it in your periodic table, remembering that you have this handy chart of ions, and on it you can find any of the polyatomic ion names and formulas that you need. So using these different resources, let's go ahead and just name some ionic compounds. First off, we have this one here, RH bracket Cr2O4 bracket 2. So again, going through this step-by-step process, the first thing we want to do is recognize right away, I have a polyatomic ion here. How do I know? Because I have more than one element symbol in the more than two element symbols in the compound. So a simple ionic compound would only have two elements present. But here I can see I've got RH, Cr, and O. Therefore, somewhere in here there's a polyatomic ion. The clue is that you have brackets around the Cr2O4, which is a dead giveaway that there's my polyatomic ion right there. So RH must be a metal in that case, because ionic compounds are always formed by metals and another anion, or ammonium, which is the only possible polyatomic cation that we could have. So here RH must be a metal, so I'm going to look this up on my periodic table, and I'm also going to look up the name of this compound right here on my chart of ions, because I know this one is polyatomic. So let's first name the metal. We go to our periodic table. I'm looking for the metal RH. I see it here in group 9. It's rhodium. And the first thing I need to check always when I'm naming ionic compounds is this metal multivalent? And the answer is yes. There's two possible charges listed here. I must include the charge when I write the name. So this is rhodium, and I'm going to leave a space in brackets for the charge on rhodium. It's going to be written as a Roman numeral, but first I have to figure out what that charge is. The next thing I'm going to do is figure out what the name of my polyatomic ion is. I've got Cr2O4. Let's look that up. I'm not going to find it on my periodic table, so I go to my chart, and Cr2O4 is, oopsies, just let me find my cursor. Let me scroll down here. Here it is down at the bottom. There we go. Cr2O4. It's called oxalate, and it has a 2 negative charge. Okay, and that's important to us too. So I'm going to write that over to the side here. Cr2O4 2 minus is called oxalate. And remember that you do not change the ending of a polyatomic ion. Normally when it's a non-metal as your anion, you do change the ending to IDE, but you do not do that when you have a polyatomic ion. You leave it exactly as it is. So I'm almost finished this. I just need to figure out what's the charge on rhodium. So I can bring the charges back up. This is going to be 2 plus on the rhodium, and this little invisible 1 can be brought up over here. And I see that -1 is not the correct charge for the anion. I know that oxalate has a 2 minus charge, so I need to multiply this by 2, and I'm going to do the same thing over here to the metal. So I know that rhodium actually has a 4 plus charge, so that it can be balanced with oxalate, which has a -2 charge. So there's my answer. It is 4. And I'm going to put that 4 right in here in brackets after the metal. But I don't write 4 in this form. I write it as a Roman numeral, which is 1 before 5. And there it is. Rhodium 4 oxalate is my answer. Let's do another example. Here I have LiCH3COO. Wow, right away I know I have a polyatomic ion because I see all of these element symbols. So that's a giveaway to me that I definitely am dealing with a polyatomic ion. Where is the polyatomic ion? Well, you have to think about where you're going to break this ionic compound apart. So where's the anion and where's the cation? It turns out that we would break it apart right here. And you might recognize that right away because you think to yourself, hey, I've seen lithium before, Li, that's a metal. Or you might recognize the polyatomic ion, which is acetate here. Or if you don't recognize it, then you would start by looking up anything that starts with Li on your polyatomic ion chart. And you're looking for something more than just Li, like LiC, LiCH3, and you're not going to find it. Okay, the only possible cation, which I've mentioned before in another lesson, that's polyatomic is ammonium. That's the only polyatomic cation that you can have. So the only thing you're going to see at the beginning is either going to be a metal or ammonium. That's it. So there's no polyatomic ion here that starts with Li. All you have is lithium, which is just a simple metal ion. So that means that we would break our compound in half right there at the lithium. There's my cation, and this whole unit at the end is my polyatomic ion. And I need to look it up on my ion chart to figure out what its name is. And so let's do that right now. So I'm looking for CH3COO, and it has 2 names. Here it is right here. It's listed as ethanoate and acetate. Most commonly we use the term acetate when we're naming it, but either one would be correct. So I'm going to call it acetate. So I'll write that here at the end. I'm working backwards a little bit here, aren't I? Okay, but we still need to write the name of the metal first in front of the anion. And so let's look up lithium. And if you don't know it's lithium, you're looking up Li, and it's right here. It's in group 1. There's lithium. It is not a multivalent metal, so we do not use Roman numerals for this one in the name. So the answer is lithium acetate. Just like that. We're not concerned about the charge on lithium because we know it's +1, and we don't have to write the charge in the name because it's not a multivalent metal. A little bit less work when we don't have a multivalent metal. Here's another example, NH4Br. Okay, again, looking at it right away, recognizing that I see 1, 2, 3 different elements in this compound. I have to have a polyatomic ion present. The question is, where do I break it up? Well, I know that this compound cannot be ionic and start with nitrogen. In other words, nitrogen cannot be an ion on its own in this compound because nitrogen would be a non-metal. And I know that ionic compounds either start with metals or ammonium. That's the only polyatomic cation that we have. So there's a little bit of a hint there. You're going to be looking for NH4 on your chart. And hopefully by now you're starting to recognize NH4 as soon as you see it. It is ammonium, it is a polyatomic ion, and there is the name. So ammonium is the first part of my name. Okay, and that deals with the NH4 plus ion. And the second part of the name then is going to refer to the bromide ion here. Okay, Br is a non-metal. I go to my periodic table, I look up Br. On the non-metal side, it's bromine, and I have to change the ending to IDE. So this is going to become bromide. when I change that ending. And that is all I need to do for this, this name. Here is another example, MNN. Okay, right away I know there's not a polyatomic ion present here. Why do I know that? Because this is a binary compound. Binary means that the compound contains two elements exactly, and I've got Mn and I've got N. So I know that I can divide this compound right here. Mn is my positive ion, N is my negative ion, and I need to go ahead and figure out what the names of these two elements are. So Mn, I'm going to look it up. It's a metal. I need to look it up on my periodic table, and right away I'm always looking to check to see if it's multivalent when I'm looking at metals. And Mn is here in group 7, and be a little bit careful with this one, mostly when you're naming it, because the name is manganese, which is very similar to the name magnesium, and students often make the mistake of interchanging those names. Good to be aware that there are a couple of names on the periodic table that are somewhat similar, and these are two of them. So Mn is manganese, and we can see that it is multivalent, so I need to include Roman numerals in my name. So I've got manganese, let's leave some brackets for my Roman numerals, because I'm not sure yet what the charge is on manganese. I know there are 3 possible charges listed. And the second part of my name is naming my non-metal ion, which is N, that's nitrogen. Here it is over here. And the ending of nitrogen will be changed in the compound name to nitride. Also notice that it has a -3 charge. So I'm going to change the name from nitrogen to nitride. And finally, let's right over to the side, nitrogen has a -3 charge. If we're using the swap and drop method, okay, or the reverse, bringing up the reverse charges, I would bring up the little invisible ones here, and I would do the same over here, +1 or 1 plus. Okay, and then before I finish, I double check, is the charge -1 correct for my non-metal? And it is not. Nitrogen has a 3- charge, so I need to multiply that by 3, and I need to also multiply this by 3 as well. I'm just going to write that correctly with brackets. Okay, so I'm going to multiply both by 3, so that means that really what I have here is manganese 3+ with the nitride 3- ion, and so I need to write this charge of 3 into the name, but I don't write it with a 3, I write it as a Roman numeral, which is 1, 2, 3, just like that. Remember, you do have that chart in the lessons, and you may like to even just print that out for yourself, or write it down somewhere on a sticky note that shows you how to write all the different Roman numerals from 1 to 7, which are the ones that we commonly use in chemistry. So there's my answer, manganese 3-nitride. Let's do the opposite now and write some formulas given the names. And these ones are usually a little easier going this direction, because there's often some hints when you look at the name. For example, on the first one here, I notice that I have molybdenum 2. This 2 tells me right away that this gives me a lot of information. First, it tells me that I have a metal, because I only ever see these Roman numerals for metals. It also tells me that this metal is multivalent, because I have the charge listed, so we only list the charge when it's multivalent. So right away I know I have molybdenum 2+. There's my metal. And I need to look up on my periodic table what the symbol is for molybdenum. I'm just going to very quickly clean up my table because I've got lots of writing on it here. So I'm looking for molybdenum on the table. I'm looking in the metals. I'm looking in the center because I know it's a multivalent metal which exists within our transition metals, and I see it right here. It's in group 6, and it is MO is this symbol. So MO, and I know it's a 2+, so let's write that in right away. And then the next step is to name the anion, which in this case is iodide. Iodide is simply an iodine atom that has become an ion, and so I'm looking for iodine on my periodic table on the nonmetal side, and it is here, and it has a -1 charge, and the symbol is simply capital I. Notice that if you like to look in one place, your common ions are all listed on this common ion chart, and you would see on the negative anion side, very likely, I'm guessing, iodide is on there, right there. Okay, so you could have also just looked there if you want to save yourself a little bit of time. This is a handy place to start. Okay, I'm almost done. I simply need to swap and drop my charges now to finish up my formula. So I'm going to bring down the 2, and I'm going to bring down the 1, and then I clean it up, because remember that we don't keep subscripts of 1 in our formula, and we also look for anywhere where we can reduce, and in this case we can't, so the formula is simply MOI2, and I'm done. Let's do another one. I've got calcium hydroxide next. So calcium, I recognize this has to be a metal. The only possible polyatomic ion that I could have at the beginning of an ionic formula would be ammonium, and I don't see ammonium. It says calcium, so I know I'm looking for a metal, and I go to my periodic table and I'm looking for calcium, and I find it. It's in group 2 in the alkaline earth metals, and its symbol is Ca, and its charge is 2+. Okay, the next thing I need to do is look up the anion, which is hydroxide, and hopefully by now you're starting to recognize some names of polyatomic ions. This is one of them. Hydroxide is on our chart. It's OH-. There it is, hydroxide. And so I'm going to go ahead and write that formula in. It has a one negative charge, and so I can go ahead and bring those charges down now. Going to bring down the 2, going to bring down the 1, and then I'm going to clean it up a little bit. So I have calcium. I don't need to write a subscript of 1 in. I am going to write the hydroxide in, but I need to be careful before I do this. This is not correct. I must have brackets around the hydroxide ion and then the 2 outside of the brackets for it to be correct. If I don't put brackets there, then it tells me that there is 1 oxygen and 2 hydrogens. But in fact, there's 2 of this ion. So I need to put brackets around the ion and the 2 on the outside. And there is my answer for this one. Let's do 2 more together. Sorry, 1 more together. And this one is ammonium carbonate. Again, hopefully you're getting familiar with some of the polyatomic ions, but in case you're not, ammonium, you could spend some time looking on your periodic table. You won't find it. It's not a metal. And so I'm going to go to my chart of polyatomic ions, and ammonium is right here on the left-hand side under the cations. It's the only polyatomic cation that we have, and its formula is NH4+. So let's go ahead and write that one down. NH4 plus 1. And carbonate is also a polyatomic ion. How you know that this is not carbide, okay, is the ending. The 8 tells us that we are not dealing with a non-metal here. This is not carbon that has become an ion. This is a polyatomic ion, carbonate. Okay, it does not end in IDE. So go straight to your chart of ions and you're looking for carbonate. And you'll see it, they're alphabetically organized here. Carbonate is a very common ion. It's CO3, 2 negative is the charge. So I write my charge in, and then I'm going to go ahead and bring the charges down. So I'm going to bring down the 1, I'm going to bring down the 2, and then I'm going to clean it up. So I've got NH4 needing to be in brackets. I need to put that in brackets because I've now got a 2 as a subscript, and it's important that I separate that out with a bracket so it doesn't look like I'm writing 42 hydrogen atoms. And then CO3 is the anion. Do I need brackets around it? I don't, because I only have 1. And I don't need to put the 1 in the formula. I also don't need to have brackets around the carbonate here. So this is my answer, NH4 2CO3, ammonium carbonate. I hope that you will try some of these from the Hebden textbook and just continue to practice with them, and they do get easier and easier as you do them. The more you come across the different types of polyatomic ions and you get used to the names of metals and nonmetals on your periodic table, it just gets easier and easier. Good luck!